Oh my God, Bronco, let's do another problem and check it. Why are we doing this?
I don't know.
I don't know either. Maybe we need the experience. So what did we do? We did two distinct real answers. We got to do something with trig. So we're doing a trig example. So here's the original differential equation, initial conditions, and this is right off of the table from your piece of paper, plus or minus 3i for lambda 1 and lambda 2. And we don't do the eigenvectors with those guys. We do the sines and the cosines. We run right over here because we got 3i, it's cosine 3t, sine 3t, and we do kind of like the educated guess bit, where we say, okay, y of t has to be a cosine 3t, b sine 3t, and x has to be the derivative of y. So that's negative 3a sine 3t and positive 3b cosine 3t. So it's just the derivative of these guys carrying those things with us. Then we take the initial conditions. And it's supposed to be that x of 0, y of 0 is equal to 3, 2. And if you put in 0 for each t, notice a beautiful thing happens. What's the sign of 0, Bronco?
0.
And the cosine of 0 is 1. So we always get somebody to survive. We get the b, we get the a. We find out the b has to be equal to 1, the a equals 2, which gives us our final answer. We're done. We solved the system. No need for eigenvectors. Very cool. Skip, the book section that does the eigenvectors, skip it because this is much faster. So now we're going to do the weird check. So you can see over here, the matrix A, that's matrix A. We did the inverse ourselves. If you want to, multiply these two together and you'll get the 1, 0, 0, 1 identity matrix. So now I'd like to get that A inverse times y prime will get us back to this. So we're going to do this calculation. We're going to do it over here on this board. So give me y prime, vector y prime.
We have sine, or because it's derivative of sine is a cosine, so it's negative, is it 18?
Yep.
Cosine of 3t.
Good.
Plus.
Minus
9 cosine of 3t.
Sine 3t.
All right.
Otherwise, very good.
Okay.
Try it again.
All right. The bottom one is, so the root of a cosine is negative sine.
Yeah.
So it's negative 6 sine.
Good.
3t.
3t.
And plus cosine 3t.
3 cosine 3t.
Okay, 3 cosine.
So good. That was so good.
Almost.
Now I'm going to erase.
Almost perfect.
Yeah, almost perfect except for the numbers. You're off by a constant. So I'm going to do that matrix. I hope I can remember it. It's going to be the matrix 0, negative 1, 9, 1, 0. Is that right?
I think so.
Is that right? It should be, yeah, that looks good. And it's times this thing, the negative 18 cosine 3t minus 9 sine 3t. I'll get out of the way. Negative 6 sine 3t plus 3 cosine 3t. Is it right? So I have to do 0 times all this, that's 0. 1 times all this. So my top line, my x of t is supposed to be equal to this, negative 6 sine 3t plus 3 cosine 3t. It works. Negative, so point to it again, Bronco.
Right here.
Yep. That's why it's handy having Bronco. It's another set of arms to point at stuff. Now let's go for this other one. It's going to be a negative 1/9 times the whole top row. So I'm going to get a positive 2 cosine 3t. Does that look good?
Right there,
It does. Son of a gun. And then I'm going to get the 9's cancel and the minus signs cancel. I get just a plus sine 3t. We got it. It worked. It's so weird that it works with the trig because the trig we treat it differently from the rest of the gang. But the check using the inverse works. Okay, ladies and gentlemen, that's the videos for this week.
Hey, that was a quick one.
That was a quickie.